Hey, I'm Ryan from ngrok, and today we're continuing our chats with Sam Rose from ngrok, who is implementing a Kubernetes cluster in the browser. So, Sam, why don't you catch us up with where you were basically at last time, and then what you've been working on recently?
Yeah. How long has it been? 2 weeks? Something like that since we last recorded?
Yeah, about that.
I have been in Kubelet hell, I think. So the strategy I took was to get something relatively small working, which is where I was kind of very shortly after that when we last recorded. I'd got a somewhat working demo going in the browser, but I had done it by hacking a lot of things together in a way that wasn't like true to life, like the way the actual Kubernetes source code works. And I've been kind of working around that for the last couple of weeks to go through all the components and make sure that they have parity with the upstream code. And that involves a heinous amount of reading Go source code. I would have the TypeScript version up and the Go version up, and I would be doing line by line comparisons. And I've been doing that for 2 weeks, more or less. And I've been doing it from the outside in. The kubelet is like the center of the world in terms of Kubernetes. It is a very large, very complicated beast, and lots of different components are brought together in the kubelet, and they kind of work together in different ways. They have channels passed between them so they can send messages from different components and get replies back. There's a lot of just a lot of stuff happening in the kubelet. So I did a lot of surrounding work. So all these components that communicate with the kubelet were done first. And those components themselves depend sometimes on other components. So you get this kind of ballooning circle of things around the kubelet. And then working my way in until last week, I finally got to the point where it's, okay, it's just the kubelet left. Or at least so I thought. Since then, there's been several bits where I've realized, oh, the real kubelet has one of these things, and I don't have that. And you have to kind of figure out, why don't I have that? Do I actually need it? Is it superfluous to the project? So yeah, lots of reading, lots of parity work. I didn't just want to, because I'm using LLMs fairly heavily in this project, but I don't want this to just be slop. I don't want it to be a slop port. I don't want it to be low quality. So everything that the LLM is producing is being very scrutinized by human beings, by me, to make sure that, when I read the two things side by side, I can confirm 100% that this is doing the same as that.
Mm. And I can understand that it's important for you to understand every line of code that's written, because when you throw this in the browser and you start to use it for real, you need trust and certainty that it's behaving the way it's meant to be behaving. And that's because you have a deep understanding of the implementation that you've created.
That's funny. So, sort of. I agree with the first part where this, to me, like accuracy and correctness are the absolute primary goals, because I want to use this to educate people on how Kubernetes works in various ways. If it's not correct, it's just pointless. There was no point in doing this at all. So correctness, very, very top of mind. It's interesting. So you would think if you've ported something from one language to another, you end up understanding the implementation. It's actually not necessarily true. It's very easy to compare two pieces of code and be able to say, yes, they are doing the same thing, but not to really understand how they fit into the broader picture. And there are definitely components where I've effectively ported from one to the other, and I still don't fully understand how it slots into the picture. I have certainly a much better understanding than I did before I began this project, but I would never claim at this point that because I have read all of the implementation, that I actually understand why it's all there and what it's for, especially because parts of the implementation are quite esoteric and strange. So yeah, it's and that's, kind of scary for me to admit in a recorded medium that, yes, I don't understand all of the pieces of this thing, but I think there are definitely parts of it that you don't really need to. Like, there's lots of caches lying around that yes, this cache is something, I don't know exactly what, but it's I can say for certain that it's doing the same thing as the upstream code. But yeah, I don't have a full understanding of how everything works, even after having read it.
Mm. So since you've been in Kubelet hell, Has there been sort of like any interesting learnings? Because I know you were mentioning in the previous episode that you bought a book on Kubernetes internals because there were so many things that you needed to understand. Has there been any interesting insights that you've discovered since you've been working on the kubelet?
Definitely a better understanding of just how much work is done to keep up to date with the world around the kubelet. Because the kubelet coordinates some external systems. So the container runtime, the thing that actually runs the container, isn't in the kubelet. The kubelet talks to it over gRPC, really interestingly. Like, I didn't realize, like, if you're using Docker, that then there's a gRPC interface to it, which I didn't realize. So it's doing a lot of work to make sure many external systems are in sync with each other. And there's a lot of ways that they can't. Sometimes they're not in sync with each other. So it's really odd sometimes reading through the code that's part of the what they call the reconciliation loops. So the kubelet is always looping and reading state and making sure that matches other state. So it looks at what's in the API server, so your pod manifests, and then it looks at what's happening in the container runtime on the node. And it's like, do these two things marry up? Are they in sync? And then it because this loop is meant to be fully idempotent, so you can run this loop at any time and it should make progress towards reconciliation. There are places which I find quite interesting where, excuse me, it just bails out of a loop at one point. And maybe it's done something, but I would have expected it to actually do more after that. But it bails out of the loop and it will have a comment saying, like, the next iteration of this loop should catch that we've changed something and move the whole process along. So it's a way of thinking I'm not as used to as a mostly a back-end web developer in my career. You have a piece of work to do and you do it. Whereas in the kubelet, it's like you have some state to reconcile, and provided you make some progress in every iteration, you're all good.
Interesting. So yeah, it's an eventually consistent model instead of start, stop, and then we're done.
Yeah, exactly. You could even joke that it's like a potentially consistent. Because I'm not sure like how much it guarantees in every iteration some progress will be made. I can imagine having read, and what I have seen in what I have read in the code, there's potentially situations there where you could get a little bit locked and a little bit like, well, no progress can be made from this state. Like, there's lots of code in the kubelet which I and ahed about bringing across because it's talking about situations that I know aren't going to happen in the browser. As an example, the kubelet does a lot of locking in a lot of places. So it will lock a mutex, mutual exclusion lock, to make sure that these modifications happen and nothing else can interfere with them. And there's a lot of places in the browser I actually don't need to lock. So you might be thinking, well, it's the browser, it's single-threaded, you never need to lock, right? And that's not true. There are places that you do need to lock. And the reason behind that is every time you do an await, so you await like an async function or something like that, another promise is going to start running and it could potentially interfere with some work that the previous promise has already done. So even though it's single-threaded, you can have concurrency problems. But if your function is not async, there's basically no need to lock anything because you know it's going to run start to finish and nothing is going to interrupt it. So there is like, should I bring this across? Should I not bring this across? Questions. And typically in the case of locking, I have erred on the side of not bringing them across just because I know for a fact, like it just doesn't need locking and it would be pointless to bring it across. But there's lots of stuff like that they talk to the operating system in ways that I don't need to care about, or there's this whole subsystem. I believe it's in the pod lifecycle event generator. This is a thing that looks into the container runtime and looks for like non-intentional things that have happened. So for example, if a container dies of its own accord, like it crashes, the PLEG, the plague, recognizes that and informs the kubelet, like, this thing has died. You probably need to go and reconcile this pod in some way. But there's a lot of ways that pods and containers and things like that can die in the real world that just aren't going to happen to me. Like, nothing is ever going to lose network connection because everything is running locally in memory. There is no network connection to be lost necessarily. Maybe I should simulate that at some point, but for the time being, there is no need to care about it. So the question then is like, do I bring that code across that deals with like network failures? And I have erred on the side of yes for that stuff, because in future I maybe will inject like network failures into the cluster network that I'm simulating. So yeah, there's a lot of like things I wouldn't have thought, or things I've had to kind of think very hard about whether I copy them or not in the kubelet.
So when we spoke last time, I don't know if you recall, but I'm curious, like how many lines of code, like how many lines of TypeScript are you up to at this point? And also how many, like how big is your test suite?
So, for context, we're recording this on Monday morning, my time. So it's been a couple of days since I've looked at any of this. When we recorded last time, I believe I was in the region of 20,000 lines of code, something like that. And we're double that from that time. So in the last 2 weeks, added about 20,000 lines more. And it's funny because last time we spoke, it was pretty functional in its, like it was taking some shortcuts here and there, but it's pretty functional. And at the time, I did not expect to have to write 20 more thousand lines of code. But there is just a surprising amount of things going on variously within the kubelet that I do want to bring across for the maximum possible accuracy and correctness. I would guess that I'm now probably like 80 to 90% towards the finish line. And I've been estimating that for a long time, so don't take that with any kind of certainty. But I am going through the kubelet, and I am going through the upstream kubelet tests, which will segue nicely into what you asked before. The kubelet test suite is like 5,500 lines of Go code. There is a pretty comprehensive test suite behind the kubelet. And all the components the kubelet depends on also similarly have fairly large test suites. And I have been trying to port those across pretty much like for like as well. So a lot of the tests that I have are very much the tests that are upstream. And I'm going through the kubelet tests at the moment. My plan is to try and get every single relevant test from the kubelet. There's some tests that are not relevant, like things that are only like this test is relevant for Windows or whatever. It's never going to be relevant for me. But I'm going to try and bring across every relevant test, and I expect my testing suite for the kubelet to probably end up being several thousand lines of code as well. That will take some time, but I think it's very worthwhile to make sure that, I can then say we passed like basically the same test suite that upstream passes. So it's, there is at least some hard guarantee of some level of correctness. As for the size of the test suite right now, it is something in the region of 800, 900 tests. And that's split between, I would say maybe about 600 of those are what you would think of as unit tests. So things get mocked out. They're very quick to run. They're just testing very granular things. And then about 200 of them are what I have been calling parity tests. So those tests, they're kind of end-to-end tests. They talk to the cluster at the kind of public API boundary, which is as we spoke last time, this is the Node.js SDK for Kubernetes. The official SDK is the API service that I have chosen for the cluster. So I take the same Node.js SDK code and I run it against my simulated cluster, and I run it against a K3s cluster running in a container. And I assert that the same thing happens to both of these things. And that's how I assert kind of more coarse-grained parity between the two systems.
And because your upcoming article is going to be on probes, has that affected when you're migrating code over to the kubelet? Has that sort of affected like what code paths you're keeping and what things you're not migrating?
In the early days, it had more of an impact than it does now. So in the early days, in my head, I was like, well, I probably need to bring a very small slice of this across, right? Like I just need everything to do with probes. And as time went on, everything to do with probes actually kind of turns out to be everything. Like if I really want to feel good about it and be able to confidently say that this is accurately modeling probes, I didn't see a good way to avoid bringing the majority of the kubelet across. And it's entirely because probes depend heavily on the entire pod lifecycle. Everything that can happen to a pod is something that can happen indirectly to the probing system, because the probing system is going to be interacting with the pod. So in order to try and replicate everything. So to give a good example here, probing, your health endpoint in your probe could and potentially should, in some cases, communicate with other pods. the health of one pod could depend on the health of other pods. It's not entirely obvious to me that I think that's probably a bad idea in some situations, but I think it's probably correct in other situations. So for that, like all of a sudden, you need a cluster network, you need cluster DNS, you need to model the service with cluster IPs and things like just that requirement there brings in a large chunk of kubelet that I didn't necessarily expect to need. So yes, in the beginning, I think the idea still is, the first thing I'm going to build with this is an exploration of probes. But before that, I probably will also do a kind of, I built this Webernetes thing kind of post that talks about the process and the reasoning and things I learned in the process and things like that. And also will show off probably some nice demos of this is what it can do. So that will probably happen before this probing post. But the probing post, I think, will be the first thing I do that builds on top of this library, which is, I'm intending to publish it as an NPM library that anybody can consume and build things with.
Yeah, brilliant. Okay, so 20,000 lines since we last chatted. Has your approach to how LLMs have been involved with the project, has your approach there changed as well?
I'd say I'm using them more than I was. So in the beginning, I think we spoke about this last time. In the beginning, I was doing quite a lot by hand just to get all the right structure in place and to make sure I was happy with it. But because a lot of what I've been doing recently has been pretty much porting Go code over to TypeScript almost exclusively. LLMs. So my thought was LLMs are good at that. They're good at like rote copying from one thing to another. And they are, but they're not as good as I would like them to be. I do find that, so for example, a new subsystem appears out of the wild and I'm like, oh, well, I have to bring that over. Excuse me. I will say, first of all, let's bring the tests across. And I have a bunch of prompts that are like, when we're bringing these tests across, if any test is to do with these subsystems that we don't care about. So for example, I'm not bringing like init containers or ephemeral containers. I'm not doing anything with volume mounting. So a whole list of things in Kubernetes that are currently out of scope. And I'm like, don't bring any tests that test that stuff over. But other than that, the test that you bring over should be the phrase I'm using is a line by line transliteration from Go to TypeScript as much as possible. I read through what it generates and almost always it's done something stupid or it's tried to take a shortcut or it very often introduces helpers that do make the code cleaner, but they make it harder for me to go and say, this is line by line, what is happening in the Go code. So I have to tell it like, that helper ordinarily would be great, but this needs to really match the Go code. Just to make it easier for me to be able to say, yes, this is doing the same thing. So I wouldn't say necessarily no fundamental changes in how I'm using them, but I probably am using them a lot more than I did in the first 20,000 lines. Okay.
And what sort of models are you using for this work? Are you using Claude Code? Are you relying on Codex? Can you sort of give us an idea of, like the different models that you're using? And did I pick up that you've got sort of like some prompts that you're reusing as you go along as well?
So I'm a Codex person. I've been using GPT 5.5 pretty much exclusively. I probably should have tried some Claude. I haven't. I've been pretty heads down getting things done, and GPT 5.5 hasn't sufficiently annoyed me to feel like I need to reach for anything else. Something else I'd love to try at some point, and I have every intention of writing about open models in the future because I find them personally very fascinating. I should have, and I regret not doing this, picking up some of the bigger open models like DeepSeek V4 and GLM 5.1, or is it 5.2? I forget. And seeing how they perform on these tasks. I didn't and I haven't done it. And I'm not sure if I will, purely because this is very time-consuming work and I don't want it to take longer than it really has to. It's already, I think, taking a long time, like much longer than I anticipated it taking. And that's, making me a bit stressed. And I think the added stress of trying to get an open model that is known to not be as capable as the frontier ones would be even more stressful. As for prompting and things like that, so I don't have any skills or like prompt templates or anything like that. The main thing I am doing is just creating agents.md files. I have a bit of a hierarchy, so I have in some directories an agents.md file that just explains what that directory is for, because a lot of my directory structure does match the Kubernetes project directory structure, just to make it easier for me to review and just to make it more obvious what the purpose is here, because that there's no new ideas in this directory. This is supposed to be taken from the Kubernetes project so that it is correct and accurate. So I have a bunch of agents.md files that I iterate on as when I recognize that some similar problem is happening over and over again, I try and put something in there that will prevent it from happening. And that often helps. It rarely fully eliminates the problem, but it does make a difference. I end up, when I say specific kinds of prompts, it's just the things I end up saying more often than not. And it's literally saying as well. I do a lot of voice-based stuff. So a couple of years ago, I was diagnosed with tennis elbow. So I get, flare-ups of pain in my arms. And I'm currently going through one of those, which is, really bad timing. But when it happens, I revert to a much more voice-driven workflow to kind of reduce the load on my hands. So I do a lot of navigation of my laptop with a voice. I do not touch my mouse whatsoever. I can still do typing. So typing is less of a trigger for it than mousing is. So I will still type stuff. I'm still able to write some code and go in and make modifications, and that's fine. But broad strokes, in Slack, I am dictating stuff. When I'm communicating with the LLM, I am dictating stuff. And then actually all my machine navigation is done with voice and an eye tracker. So if I have to do mouse movements, I do them with my eyes rather than with a mouse, which I think, it gets that reaction from people. It does feel kind of futuristic. The unfortunate truth is that it's actually just kind of annoying. Your eyes are not accurate pointing devices, or at least the eye tracking devices can't accurately track your eyes well enough for them to be accurate pointing devices. So you have to make some trade-offs. So for example, when I want to click on something, I make a popping noise. So like that kind of noise, but the first pop will zoom in to where I'm looking, and then the second pop will click. And that zoom in means that the granular tracking of the eyes is less of a problem because things are zoomed in. But it is a very workable workflow, and it's something I've been kind of doing for a long time, and I'm just used to it now.
What do you use for your speech to text conversion?
So when it's in dictation, I'm using a piece of software called Voice Inc., which is like a one-time payment, just like a harness around the open, what do they call them? ASR models, automatic speech recognition models. And the model I tend to use is NVIDIA's Parakeet model, which is ridiculously fast and ridiculously accurate. There are open source variants of software that wraps these things. The one I hear everyone talking about these days is called Handy Computer. That's handy.computer. Just an open source wrapper that takes one of these open models, gives you global hotkeys to trigger dictation, and then it will paste it into the right fields and things like that. It does all the machinery around it to get the text in the right place. I recommend everyone try it. I think a lot of people's only experience with dictation is like Siri's dictation on iPhones or something like that, and it's complete garbage compared to Parakeet and the newer ASR models.
Yeah, I tend to agree. Apple markets the latest iPhones with Apple Intelligence, and honestly, if they just improved Siri dictation, I would be so happy.
Yeah, you should certainly try, if you haven't already. Try download Handy Computer and try Parakeet. It's all completely local. It's not cloud-based. I could dictate several paragraphs and it happens basically instantly. The speech recognition has gotten so good over the last 5 years.
Yeah, I think you mentioned it in a chat that we had. So I went and bought it, and yeah, I've had phenomenal results with it. And it's great because you can specify words that, that often get translated incorrectly. So ngrok is one of those. So the fact that I've set that up and,
yes.
There was a few different variations of, maybe it's because I'm an Australian of what ngrok would translate into. But it works phenomenally well. And it is incredibly fast too.
Yeah, the ngrok is I don't have many custom words in they call it your custom dictionary. But ngrok, there's so many. So ngrok, engrok. There's just so many different ways of misspelling ngrok, and I feel like now I've got pretty much all of them. But it's also not something I say all that often in speech. Like I don't say it to an agent very often. I don't say it in Slack very often. Like it's when it does come up, it's usually correct now. I think I've got all of them.
All right, so you're making your way through kubelet hell, and I think you said earlier like you're about 90% of the way there. What is sort of like on your list of things to do now between at least where you anticipate is going to be the end of the road?
Yeah. The big thing at the moment is just getting to the end of the parity check. So this whole thing has been, I need to feel comfortable in myself that what I have written is faithful to the upstream code and it's doing what the actual kubelet does. I would not feel good just like firing off a Ralph loop and being like, and then just checking in the result of that. Like just personally, I wouldn't like it. And I know that our audiences wouldn't like it. Like nobody cares about a Slop fork of Kubernetes. It's not interesting. It's not going to be useful. It's not going to be educational. So I need to feel good about what's in there. And that takes time, sadly. Like the sad truth of it is that is a time consuming exercise. And the LLMs make it faster and they also make it great for my tennis elbow because I have to do a lot less typing, which is wonderful, but they aren't going to do it right. If you think about like the Zig to Rust translation that the Bun project just did, and if you're not aware of this, Bun, the JavaScript bundler, just converted to Rust from a language called Zig, and they did it almost entirely with Claude. They have the benefit of a completely external testing suite that still exists. I think they didn't have to convert that at all. I think it's really like true, like black box testing. I did not have that. And even if I did, I would still go through the process I'm going through now, because I'm not as up to date on this as I maybe should be, but I'm led to believe that the Rust port of Bun has had a bunch of kind of new problems introduced in the process. And I don't think that's surprising. I'm not saying that as a dunk on the project. Like I'm sure they're smart people and they expected this and they're going to be working through those problems. So yeah, even if I had access to a fully TypeScript version of the Kubernetes testing suite, I think I would still go through this process. Very, very time consuming. When that's done, the next priority is open source. So get it open source. So that involves writing README, writing some documentation, making sure the licensing is all correct and respectful to the Kubernetes project. I also want to include some demos in the repo. So it's some like React components or whatever that show off how you would build visual components around this thing, which I think will probably end up requiring a bit more work on the code side of things. Like I need to be able to instrument the cluster network to know like when requests are traveling between pods and stuff like that. I don't have that in yet, but I'm not anticipating that being a huge lift necessarily. So open source would be the big one. And once it's open source, to get a post out about it. And I'm imagining that post ending up using the demos that are in the repo in the post, and also just talking about the trials and tribulations of it. And then, referencing these videos as well. Like we have done these videos talking about the process. And then from there, after that, the probing post, like full steam ahead on doing something to do with probing.
So from a UI perspective, you're getting the kubelet working, you're getting all of the pieces in place. What is the browser experience going to look like?
I'm not 100% sure yet. One of the nice things about this is you can visualize stuff however you want to. So you could have a whole cluster running and you could decide to just visualize what one pod is doing, or you could decide to visualize just what two of the pods are doing if those two pods talk to each other. You could have the same cluster visualized in many different ways. Like some of the components that I've spun up just to test things, I can pass the same cluster into like 4 or 5 different components. So changing the cluster changes 4 or 5 different visual components. The possibilities really are endless in that regard. But for the demo component, I'm probably going to end up just doing like a full cluster visualization, as you'd imagine. So like boxes representing nodes, and then pods in those boxes, and containers in those pods. Just to give a full, like, hopefully something with a bit of wow factor. Hopefully something a bit that feels like visually ngrok, so using our Mantle component library and things like that. So yeah, I've not fully decided yet how a probing post, for example, will end up looking. That's something that I will figure out as I'm doing it. But for the demo, I definitely want to do just a full show as much as possible in one visual. Like, it doesn't necessarily have to be that understandable. It needs like the wow factor, and it needs to kind of showcase like all of this stuff is really happening.
Yeah, and I'm sure that's going to give people some ideas that might apply this in an educational setting. Because I remember one of the things that you said from the previous interview was that you hoped it could be used as a pedagogical artifact. And I know when I was learning Kubernetes, it's very difficult to visualize things like the reconciliation loop with pods going down and then being brought back up. So yeah, I'm really excited to see A, your demos, and B, how this could be integrated into educational Kubernetes materials. And if folks can see how things are working visually, I not only think that could mean that more people can take on the challenge of learning Kubernetes, but I can also imagine folks being able to get a much deeper understanding of what's happening as well.
That is the dream. And did I actually say pedagogical artifact? God, what is wrong with me? But yes, that does sound like me, I suppose. It is the dream. I think I said that last time as well. It is a dream for other people to kind of like find use in this tool. I don't want it to just be something that we gatekeep and this is our competitive advantage. I want this to kind of be the rising tide that lifts all content, so to speak. And I think one of the things I'd love to pursue after a Kubernetes probing post is a kind of Kubernetes beginner kind of thing. So just cover the fundamental concepts, cover the idea of labels. I think are a really fundamental concept that people don't like. Unless you've gone to some specific effort to learn Kubernetes, you probably don't really understand labels, but they're so fundamental to how everything works. And that could be something that is then visualized. Now, like you said, the pod lifecycle as well. Like another thing I want to be experimenting with here is just the interactivity. Like one of the things I made sure was in and working is you can create node port services in Kubernetes. So basically what that means, in a real Kubernetes cluster, a service is an IP address that allows you to talk to either one or more pods. And a node port service exposes a port on every single node that will load balance between the pods within the service. And I wanted this because it is the way that I intend to communicate with pods within my simulated cluster. So I have node port services, and in my cluster class, you can do a fetch call on a specific node port, and it will talk to the service that those pods that is representing those pods. And then those pods can be programmed to do whatever. So you are literally sending them like fake HTTP requests. So I could have pods that in the visual, let's say you click on a pod, I could send an HTTP request to that pod that tells it to crash. And then the pod the PLEG, the pod lifecycle event generator, will realize that's happened, and the kubelet will bring it back up again. So there's all sorts of things, like not just you can show these things happen, but you can say to the user, you can influence this and see what happens in a safe environment that doesn't require you to install K3s and learn how all the manifests work necessarily. So yeah, I have big dreams around this, I guess.
Yeah, I can imagine that too. Like being able to just click on a pod, like and kill it, and then see what happens in real time, and see, just that visual map of how one thing affects something else. And I think that sort of speaks to what your interactive essays are legendary for. Is it's not just a bunch of information; it's the fact that you can interact with things to see the effect that one thing has on another thing, which for the reader, just makes learning not only like more fun, but it deepens the learning experience as well. So, I'm excited to be able to actually get my hands on it and use it soon. So between now and the next time we chat, I think maybe a week or so, it'll be interesting to see where you're at, because it sounds like you're actually pretty close now.
I would hope in a week's time it has been open source. That's my hope. I think it may not come to pass, but when it does come to pass, it will not be much longer than that. Like don't want to get anyone's hopes up. I don't know. It just feels like that's a pretty reasonable timeline, I think, for this to be an open source thing that people can go and kind of poke and play with. Yeah,
that's excellent. Well, Sam, it's been fun, and we'll catch up in a week or so. And in the meantime, mate, good luck with it all.
Yeah, thanks, man. Thank you.